Welcome to a brand new video on integration by parts. This is the third example. It's the integral of ln of x all squared dx. Yeehaw! So now you choose the thing that looks the scariest to be a u. I'm circling it. It's ln of x all squared. And the reason why it's ln of x all squared is you'll find that if you don't do that, you will get the wrong answer. And the reason why is because when you do an integration by parts, everything has to be included. Like, you have to take into account everything. What's your u, what's your du, what's your dv, what's your dx, what's your v. Cool, so u du is equal to, now how do you take the derivative of 2 ln of x all squared? Well, power rule, so the power comes in the front, so 2, and then multiplied by just ln of x, so you leave ln of x like, you know, chill banging. And then you take the derivative of ln of x. Man, my hand was in the way, phone. Dude, I can't speak. So now what's the derivative of ln of x? So the chain rule, well, that's just 1 over x. Well, it's just, yeah, I just told you the answer. So it's 1 over x and it's dx. Cool. Now what's dv? Well, dv is the one I have to integrate. So now I'm integrating dx. So you see how everything's been included? I've made u equal ln of x all squared and dx is dv. So now I've literally made f of x and, well, f of x g dash of x, yeah? Because this is f of x, this is g dash of x. This is obviously just dv, and f of x is obviously just u, if that makes sense. Anyways, so now what's the integral of dx? Well, that's just v is equal to x. Cool. Now what's the integration by parts formula? Remember, when you do an integration by parts, you're not even making a change of variable. It still stays in x, which is kind of cool. So now, the integration by parts formula is uv minus the integral of v to u. I've said that a million times over. I can say it super fast. It's like a tongue twister, man. So u is ln of x all squared, yeah? And v is x. So I'm just going to bring the x out the front because it looks more aesthetic. Minus the integral of v to u, which is x, and du is 2 ln of x all over x dx. Isn't that fancy, man? You already know. Now I'm going to rewrite the integral. I need to die. So minus the integral of 2 ln of x dx. Now we do integration by parts again, man. And the reason why is we can't integrate ln of x. So I'm going to bring the 2 out the front, and I'll show you exactly why. So it's x ln of x all squared minus 2 bracket, because I know that I'm altering this integral, which means that I'm doing integration by parts again. So this minus sign is going to apply to this integration by parts problem again. So u is equal to ln of x du. Well, we know the derivative of ln of x is 1 over x dx. And dv is equal to dx, which means that v is equal to x. Isn't that cool, man? So now it's uv minus the integral of v to u. So literally like that. Like, you can draw a diagonal arrow. And then like, you know, go this way. It's like that's like, you can make that like your own little way of thinking about it, like diagonal right and then left. I don't know. So ln of x uv, so x, that would be confusing if I had the x there. So x ln of x, I'll put it in brackets, minus the integral of v to u, which is this x times 1 over x dx. Cancel. Yeah, buddy. So now it's x ln of x all squared minus 2 ln of x. So I'm expanding it out already, man. So minus 2 ln of x. Now minus 2 times minus the integral of ln of, well, this is the integral of dx, yeah, because the x is cancelled. So that's the integral of 1 times dx. And the integral of 1 is literally just x. So this is x, but it's minus 2 times minus x, which is plus 2x. And then plus c, of course, your arbitrary constant of integration. And that would be the final answer. So that's what the integral is. So cheers for watching, and I hope this video helped, and I'll make some more videos in the future, man. See you later.